Biodegradable polymers, they break down and lose their initial integrity by bacterial decomposition process. Generally, bacteria release enzymes. These enzymes show action on the plastic material and breaks the bonds between the polymer chains and converts into small molecules like carbon dioxide, nitrogen, water, biomass, and any inorganic salts. Here you can see one picture. This is a plastic bottle made of materials like polylactic acid. It is a biodegradable polymer, and a few days, about some 70 to 80 days, converted into the soil. In this way, biodegradable polymers act. These biodegradable polymers, there are many natural biodegradable polymers like polysaccharides, starch, cellulose, etc. And synthetic polymers. These synthetic polymers are obtained from the natural polymers only. And mostly these biodegradable polymers consist of the ester, amide and their functional groups and can be synthesized by condensation reactions, ring opening polymerization reactions using metal catalyst. And there are diverse applications we have, such as surgical stitches. So this is surgical stitches, wound dressing, tissue regeneration, enzyme immobilization, controlled drug delivery, gene delivery, tissue engineering scaffold, cryopreservation, nanotechnology, medical implants and devices, prosthetics, augmentation, cosmetics, sanitation products, coatings, adhesives, and many more. Plastic packing industry. Now, these are the few examples of biodegradable polymers obtained from the renewable sources like starch and cellulose. Polyglycolic acid, polylactic acid, polyhydroxybutyrate, PHB, polyhydroxybutyrate, co-beta hydroxyl valerate, polycaprolactone, nylon 2, nylon 6. These are the biodegradable polymers which are processed from the polysaccharides such as starch and cellulose. Now, in this video, we'll discuss about the polylactic acid. This polylactic acid is a thermoplastic aliphatic polyester which is derived from the natural sources or renewable sources such as cornstarch, tapioca roots, chips or starch or sugarcane. Now, the synthesis of lactic acid is simple from the bacterial fermentation process by from the starch or cane sugar. By bacterial fermentation we can produce the lactic acid. This lactic acid cannot be polymerized directly. If so, this polymerization produces the molecules of water. This water again degrades or breaks the ester bonds in the polymer chain. So due to that reason, first it is converted to dimeric or dimerized into a dilactic ester. This dilactic ester is subjected to the ring opening polymerization reaction. Here you can see this is the lactic acid first converted into a dilactic acid ester, which is a ring, and it is subjected to ring opening polymerization reaction in presence of a catalyst stannous octet. So this step yields more polylactic acid polymer compared to the direct polymerization of lactic acid into the polylactic acid. And come to the properties of this polylactic acid. Like other plastics, this plastic also can be converted into fibers and film form, and it ranges from amorphic glassy polymer to semi-crystalline and highly crystalline polymer with a glass transition temperature of 60 to 65 degrees Celsius, and its melting point can be is around 190 degrees Celsius, can be increased from 40 to 50 degrees Celsius, and the heat deflection temperature can be increased from approximately 60 degrees Celsius to up to 190 degrees Celsius by blending the polymer with polydilactide, and it is soluble in solvents like hot benzene, tetrahydrofuran, and dioxane. And applications of this polylactic acid, it can be processed like plastics, extrusion, injection molding, film and sheet casting, and spinning, providing access to a wide range of materials. Here you can see this is a extrusion, tube form extrusion, straws, and this glass film form, and this is the packing cover, tea bag cover. And these are made of the polylactic acid, and these are the fibers used for the 3D imaging technology. And next, applications like upholstery, disposable garments, awnings, feminine hygiene products, and diapers. You can see all these in this picture. So these are the diapers, or cosmetics, and the electronic gadgets, and packing, food packing, etc., etc. And not only that, they are extensively used in form of anchors, screws, plates, pins, rods, and as a mesh. You can see this is one example. These are the polylactic acid screws which are used in the orthopedic surgeries. And this is the mesh made of the polylactic acid. And see here, this picture simply depicts the complete polylactic acid. Here this is the corn, and this corn starch on fermentation produces lactic acid. This lactic acid is converted to dilactic acid, dimer of the lactic acid, again on ring opening polymerization reaction converted into polylactic acid. After its intended use, this polylactic acid is degraded into the lactic acid. Further, it is undergoing biodegradation to release carbon dioxide and water. In this way, polylactic acid is completely biodegradable. Now, of this usage, it is used in medical field, packing industry, and in the form of fibers, and other materials in domestic purpose. This is all about the biodegradable polymers and polylactic acids. So, thank you.